Hi, and welcome to the session Drive Towards Better Outcomes Using CoPilot. My name is Marko Tisler, and I'm the Director of Product Management here at Extreme Networks, and I look after machine learning and AI solutions. When we were thinking about CoPilot, we were thinking about the reference that comes from aviation. And in a sense, CoPilot in the extreme cloud IQ context is very similar to what it means in aviation. It means someone or something that helps with the situational awareness of the pilot. In our case, the pilot is the person that's doing network administration. It's responsible for the health of the network. And the role of CoPilot is to prevent bad things from happening or prevent from issues from popping up. In terms of aviation, obviously the risks are much greater because most of the times lives are at stake. And with networks, it's a similar thing in terms of we are trying to prevent issues from happening or avoid issues from happening. And if they are happening, trying to resolve them quicker. So if there is an incident, CoPilot is there to help you navigate that incident quicker and hopefully also without any errors during trying to resolving that issue. So that's the similarity between aviation and networking. And when we were looking at challenges that network operations or even IT operations in a larger sense have today, it has to do about expanding environments where we have to support more customers. There's more users that are connecting to the networks. There's more nodes, more sites, so just more of everything. And at the same time, the problems are expected to be solved and addressed quicker, which basically means in today's digitalized world, we're depending on the networks so much that every minute or every downtime literally means dollars lost. In some cases, could even mean, if depending on the environment, other considerations, so not just money. And our customers are not just expected to solve problems quicker. In some cases, they're actually expected to avoid problems altogether. So they need to be navigating the complexities and the dynamics of the networks with the expectations of avoiding the problems and trying to make the network to run as smooth as possible for the longest period of time as they can. Now, what works against that is the ever-increasing volume and diversity of data that we have to work with, because when we're trying to predict and solve problems, we look at the data. We look at logs, we look at debugs, we look at different types of data sources, and with the different types of devices, applications, and just different ways we use the network today, that becomes more and more complex. And we have increasing volumes of data, and we have increasing diversity of data because they come from so many different sources, which creates the complication of how can we interpret what we're actually looking at. And this is where data analytics and machine learning come in, because they allow us to analyze data at scale. They allow us to recognize patterns automatically, and they basically allow us to do things we do manually much quicker and in an automated way. And while this might be novel to our industry, it's something that's been used in the financial industry, namely in trading, in stock trading for quite a while. And in stock trading today, you have manual and automated trading. The manual trading or the manual trades are done by domain experts that have specific knowledge about how to, more specifically when, to execute a particular trade. And the automated trading means there's algorithms that are actually doing trading in an ongoing fashion. And because they're automated, they can do that much faster than a human being can. And that slight difference in time is what creates better outcomes. But they're used together. So manual and automated trading is something that's used together. And this is how we see network support of the future as well. So there's going to be a manual part where the main expert basically guides the resolution of the case, supported by or augmented by an automated algorithm or algorithms and tooling that will help them with the resolution. And the first role of CoPilot is to gather data points that would help identify the root cause and solve the case in an automated fashion. And it solves one of the problems we see when it comes to support. And this is reactive support, where you wait for something to happen, you open up a support case, and then there's this time of back and forth between the customer or the administrator and the actual support. And what happens is there might be logs that haven't been collected, or in some cases, maybe there's a lot of time pressure and there was no logs collected. There's no debugs collected. And it creates this situation of back and forth, which takes a considerable amount of time before we have enough information that will help us solve the problem, that will help us identify the root cause and recommend a remediation. And so CoPilot helps in the sense where it tries to gather those data points automatically and actually equip them with the case without having to do all this back and forth between the customer and support. And the second part of CoPilot lies in its predictive and proactive nature. And it's able to detect issues based on early indicators, or it's able to detect things that would require a normal human being to look at a large number of data points across time to find that something suspicious is going on. So it's able to recognize patterns and it's able to pick out things that are strange, abnormal, and could lead to a potential device failure or a network incident or just a network issue. And it's able to bubble those up and raise them to our support. So the second part is CoPilot's predictive and proactive nature. In terms of the wider industry, we're talking about AI for network operations, and you might hear terms like AIOps, which is a very industry standard term. Or in our particular case, because we're working off of network data or data coming in from networks, we're talking about AI for network operations or AI NetOps. And we're looking at two different data sets. One is operational data. That's data that's continuously streaming in from the network devices we're managing. And the other one is service management data that has to do with the way that we configure those devices and how the services that those devices are providing are actually running. And the idea is to use this or look at these two data sets together in a uniform fashion and use all the data points across them to correlate between issues and to be able to provide as best root cause analysis or as best contextualization of the problem as we possibly can. And the whole point or the goal is to reduce time to resolution, to reduce risk of human error or reduce risk of an actual outage altogether by being proactive. So instead of waiting for an outage or instead of waiting for devices to start behaving in a fashion that would negatively impact your network, we're trying to proactively prevent that from happening by reaching out. The two data sets in a bit more detail that we collect in XIQ look like this. So on one hand side, you have the operational data or telemetry data, which consists of metrics and events in a broader sense. Metrics is time series data that are typically CPU utilization, memory utilization. If you're looking at access points, you're looking at RSSI or signal to noise ratio, number of connected clients. And events describe state changes in terms of client connectivity, so a client connected, disconnected, authenticated, deauthenticated, in terms of hardware states, in terms of software, has a software rebooted, what was the reason for the reboot, in terms of the operation of the control plane, as an example, a spanning tree protocol, a threshold crossing is event, so if there's specific thresholds that shouldn't be crossed, or if they are crossed, it means it's an indication of something going wrong. And finally, anomalies, where these are events that indicate that something has happened that hasn't happened before, or it's completely different from how this network normally operates. And the anomalies are interesting because the reason we use anomalies is to, on one hand, to get away from static baselining. So what we want to do is, normally in a network, a customer will set a threshold, and if that threshold is crossed, then there's a problem, and it's very final in that way, where the threshold really doesn't change unless the administrator goes in and fixes it. Now, what happens with the networks through time is those thresholds, in terms of their meaning, they change. So if something is considered to be bad today, that threshold might actually mean something normal in 6 months or 1 year from now. So it's for that reason we try to rely on anomalies as well, because an anomaly will simply say, well, this has never happened before, it looks different, and if you ignore it, well, then this becomes the new normal. So in that sense, anomalies are a good input in terms of events for seeing whether things are operating normally or abnormally. And the service management part of the data is provisioning, so configuring the devices, provisioning the services on top of them, audit logs, what's happening in terms of interaction between the administrator, NMS, and the devices themselves, incidents, which would mean we know something bad has happened with the network, SLAs, so are the devices connected to the network getting the SLAs that they should be getting or not, and just performance indicators like bandwidth usage, throughput, goodput, that sort of metrics. The Extremes Data Refinery looks like this, and the reason why I use the term refinery is because we hear that the term that the data is the new oil, but oil without being refined, it doesn't help us much. So it's the same with the data. We can collect as much data as we want, but if we are unable to refine it, then it's as useless as that crude oil that we collect. So the way Extremes Data Refinery in XIQ works is we collect the data from the network devices. In this case, we call that the edge. And what we also do is we do some edge processing on those devices. So we don't just stream every single data point up to the cloud, because that would be counterproductive, and it doesn't make sense from a business perspective or a technical perspective, because there is just so much data that could be streamed. So what we do instead is some data points we process in terms of, instead of streaming the data up, it's sometimes better that instead of streaming every single measurement, we collect and build a distribution over time, let's say how that particular metric looks over 10 minutes, and then we send that distribution over time is what we send up and store in XIQ. And all the data is being collected and pushed up through our data pipeline up to Extreme Cloud IQ. In Extreme Cloud IQ, that data can be interacted with in two different ways. One is through APIs. So a third-party app could tap into some of that data, or more traditionally, an XIQ admin will log into the system, and what they will see is time series graphs, they will see events, they will see logs, and they can interact with that data, explore it when they're either doing just monitoring or if they're actually doing active troubleshooting. So with CoPilot, we're layering another layer on top of that. And we also use the term explainable AI. And what CoPilot is three things, really. So we have a group of data scientists, and the group of data scientists basically goes through all the Extreme Cloud IQ data. They write and automate data analytics algorithms. They create machine learning models that focus around network health, which constitutes both infrastructure health or connected device health. And using those models, we are able to describe how a normal network operation or device or a client operation looks like versus how an abnormal operation looks like. And on an abnormal operation, we're able to then trigger a notification to GTAC that will say, well, this particular device, this particular customer is not operating as it should be. And we make that explainable. So we really believe in the explainable part, whereas we don't just give an indication that something's going wrong or something is abnormal. We also equip our GTAC and, as a consequence, our customer with the information of which are the data points that support that anomaly. So what's the supporting data like? What are the data points that would help with solving this case? And then that constitutes a proactive outreach from GTAC to customer. And between those three things, that really is CoPilot. And one of the most important things about it is we have machine learning, data analysis, and we have an automation. But what's most important, we've been focused on the explainable part of the AI to make sure that the data that we provide also helps to explain the actual anomaly or the actual incident. In terms of data, what's also important is anomalies without context of the environment are often useless or lead to false positives. So our customers in XIQ come from different verticals, and what's normal for one environment might not be normal for the other, and vice versa. So it's important that the data is contextualized in this sense. So it's contextualized in a sense of what kind of environment is this running in. And the other part is which part of the network is this data coming from? If you think about what kind of devices we're supporting, we have wired LAN, wireless LAN, so we have switches, we have access points, we have branch routers that can also run SD-WAN. Switches go from access switches to distribution to core. We have access points that are access point connected to a wire. We have mesh access points. So all of that information or the context of topology is also important when you're trying to do things like root cause analysis and trying to find out what's actually going on in the network and what's causing an issue. All the data that we're operating of in CoPilot is anonymized. And the whole process of CoPilot is compliant with ISO 27001. There's no personal identifiable information in the data set that we're working from. And the data doesn't leave the RDC boundary, which makes it compliant with GDPR. And there's no concerns around data leaking out of the RDC. It all stays right there next to your Extreme Cloud IQ dataset. In some cases, what we can do is we can create anonymous models, which are portable. So we can create a model that describes, for example, client health, which can be exported to other RDCs. Now, that's a completely anonymous model. It doesn't contain any customer or device or client-specific information, but it can be shared between different RDCs. And the benefit of that is, once we've learned that, a customer that is a new customer that hasn't been running XIQ for months or for years can immediately benefit from that knowledge for what you've learned. So that model is immediately applicable to a brand new customer that have just set up their XIQ environment. So let's go over two examples of how we use machine learning in CoPilot, two concrete examples of what we're detecting, for example. So the first one is an outlier detection model. And what we're doing here is we're looking at PoE, or Power over Ethernet, of access points. And what you see on the screen is a subset of access points, of all the access points in the system, that do have flipping between PoE and PoE plus power supply mode. So they do have this flip between optimal and suboptimal, is what we call. So optimal would be using PoE plus, but they can actually run on PoE. But when they're on PoE, they might need to turn some of the radio chains off, so they're not working in what we call an optimal way. And what's interesting for this set of devices is we have 4 different clusters of devices in here. So we have a green cluster, which is devices that operate in PoE plus mode most of the time. So that's what the x-axis means. What percentage of time are devices in the PoE plus mode versus in PoE mode? And the y-axis explains what's the likelihood that that device is going to flip between one and the other. And what we see is, so on the right-hand side, we have devices that are fairly static. Most of the time, they're in PoE plus, so they're not as concerning. On the left-hand side, we have a blue cluster, which is devices that are, most of the time, they're in PoE mode. Sometimes they switch, but most of the time, they're sitting in the PoE mode. And we have a semi-interesting group, which is the pink group, which are devices that are, most of the time they're in PoE mode, but they have a very high likelihood of change. But most of the time they will spend in PoE mode. So they won't change to the one and spend a certain amount of time PoE plus, they will just go back and forth. So those might be interesting, but what's a really interesting group of devices detected here is the red devices in the middle. And these are devices that spend 50% of the time in PoE mode, 50% of the time in PoE plus mode, and they have a high likelihood of flipping back and forth. So these devices were probably, clients connected to these devices might be experiencing issues, or the upstream switch might be having issues. Or there might be issues with the power supply going into the rack or into the MDF, or the AP itself needs an RMA. So this is an indicator that these devices needs to be further investigated, and this is where the data contextualization comes into place. We need to further explain what's actually going on with this. So, but these devices, in terms of what they are, they're outliers in the sense that they are behaving much differently than what you expect and how other devices are behaving. The second example is we use time series anomaly detection to find things that never happened before or things that are just out of the ordinary. And the reason why we're looking at anomaly detection on time series is because spikes and dips might in some cases be normal. So we need to make a distinction between univariate and multivariate time series. So in univariate time series, when you're looking at a single variable like CPU utilization, are less interesting than when you're looking at multivariate. So when you're trying to combine multiple time series together, because that will actually reveal much more interesting insights. So for example, if you just look at CPU utilization and you look at CPU spike and dip, might be normal, might not be normal, depends on the context. But if you look at CPU utilization in context of memory and number of clients connected, for example, if you have a spike in CPU and a spike in memory, with a spike in amount of clients and data going through the access point, that's probably normal. That's you would expect that behavior. But if you have a spike in CPU, a spike in memory, but there is no corresponding spike in the usage in terms of clients and actual data going through, then that's probably abnormal, and it's a bigger, it's something with a higher anomaly score, and it's more relevant to be followed up on. So finally, the insights are automatically generated. So what we do is we use machine learning to find some of the patterns I've just shown you, but we also contextualize them, and we automatically generate them. So it's not something that's done just by a manual analysis, by a human going through this. It's the human goes, or the data science team goes through this once, and then they automate the process. The process generates insights and serves them for GTech. GTech does an active follow-up with the customer. The customer will then give feedback in terms of what was this a perceived outage or a problem, or wasn't it a perceived outage or a problem, and whether remediation was successful or not. And then we feed all this information back into our machine learning and AI to improve the model in production and the actions going forward. So with more interactions we have with the customer through our CoPilot program, the better the outcomes are going to be, the shorter the time to resolution, and we will be able to reduce risk proactively in a bigger and more effective fashion going forward. So thank you very much for joining the session. Hope you've enjoyed it, and thank you for joining Extreme Networks Connect.